Okay, so this is from section 6.1 out of that David Lippman book, page, and not the page, oh, what page is it? It's page 368 in the version 2. And I thought I'd walk through this. One of you asked, so I thought I'd walk through this. And I'll probably do a little add-on, so later on in the book we see these again, so I'll add that. So here's what I do when I have to do these Ferris wheel questions. I make myself a little, so let me get a brush going. So here's the ground, here's the Ferris wheel, here's the center of the Ferris wheel, here's the stand it's on. And let's see, we know the Ferris wheel is 25 meters in diameter, so that means the radius is 12.5 meters. Okay, and then we're going to find the turning points. And we know that it starts 1 meter above the ground, so this height's 1. So, and it takes one full revolution takes 10 minutes. So at time 0, the car is 1 meter high. At time 5, it's 25. Remember, this is a diameter of 25, so 25 plus 1 is 26. And then halfway or a quarter of the way around there is going to be at 2.5 minutes. It's going to be 12 and a half plus 1, so 13.5 meters high. On the way back down, it's at 7.5 minutes, and it's back down to 13.5. And then 10 minutes around, it's back down at 1 high. So then what we can do is, let's make a little graph of this. We know it's going to be a sinusoidal. I'm going to do 2.5, I'm going to do 5, I'm going to do 7.5, and I'm going to do the 10, just so I can graph one cycle of this graph. I know it's the minimum height is 1. I know the maximum height's 26. And of course, I know from my diagram here, I know that the midline is going to be 13.5. So at time 0, it's at 1. At time 2.5, it's 13.5. At time 5, it's 26. At time 7.5, it's back down to 13.5. At time 10, it's back down to 1. So I see a cosine graph that's been reflected around the x-axis and shifted up 13.5. So we know the midline. So right now, I know the midline is y equals 13.5. I know the amplitude. Well, let's see how it changes. See how that's just the radius. So the amplitude is 12.5. The period is the next thing. I know that normally for these cosine sine graphs, the period is 2.2 pi, but this is doing it in 10 minutes. It's making one cycle in 10 minutes. So that simplifies to pi over 5 is my B number. I guess I should have answered that the period is 10 minutes. Okay, because the mistake that people will do is they'll put the pi over 5 as the period, and that's not the period. It takes 10 minutes to go from 1 meter back down to 1 meter. So that's the period. Now let's answer the question about the function. Find a formula. Well, I see a cosine graph because I know normally cosine graphs start up on the y-axis, then come down, right? So I see a reflected cosine graph. So negative 12.5 is my amplitude. The cosine is not shifted left or right, so I can just put pi over 5 times t, but it is shifted up 13.5. So that's my function, h of t equals this. So that, and then I can use that for some further work. And then say, how high are you at 5 minutes? Well, what's nice about this is we know that's one of the turning points, so 26 meters high. Okay, so that's this question. That's the question in My Open Math. I would recommend you make a sketch like this and then make a graph of those turning points, and then it's really easy to write the equation. Now, if that's all you need, stop the video, go answer that, and try question number 24 if you want. What if they're asking me some further questions when we get into section 6.4 and not so much 7.1? I guess this is really 6.4. They're going to ask me, hey, how long is this Ferris wheel? How long is this Ferris wheel or the car above I don't know, let's make the number up, 14 meters. Let's make it up. Let's make it 20 meters. So graphically, I can see this, right? I mean, you could throw this into a grapher and do it graphically. That won't get you full credit on the exam questions about this. But it's those two t values, the difference between those two t values. Okay, so how do we do this algebraically? It's not bad. Let me change some things around, and I'll come back and show you how to do that. Okay, so the equation I'm going to solve is this one. I want to know, when is that height equal to 20? So I see there's two places on this graph when the height equals 20. I wrote, oh, I don't know why I wrote 2 there. I should have written t and then t. So there's two places with t equals 20, right? And then we're looking for, and to answer the question, but how long does it stay above 20 feet? Well, we're looking, that's the arc where it's above 20 feet. We want to find those two t areas and subtract them. There's other ways to do it too, but I'm going to show you this way. So I'm going to solve this equation for t. So I'm going to subtract 13.5. I'm going to subtract 13.5 from both sides. And I think that leaves me 6.5 equals negative 12.5 times the cosine of 5 pi over t. And then I divide by negative 12.5. So that leaves me the cosine of pi over 5t equals, let's see, I won't show this on the screen. I know you know how to divide. I know how to divide 6.5 divided by negative 12.5. Except I can't, my calculator, 6.5 divided by 12.5. I'm getting negative 0.52. And then I want to undo the cosine. So I'm going to do the arc cosine of negative 0.52, and that leaves me, and that over here the cosine cancels out, right? Equals t. So I'm going to do arc cosine, let's see, let's make sure you're in radian mode first off. My calculator's in degree mode right now. So I'm going to do second cosine of negative 0.52. So I'm getting 2.118. Since I'm not trying to make my open math happy, I'll round there. And then to solve for t, well, actually, let's think about this a little bit more because we're going to do some more equation solving. I know whatever the answer is. There's two places. When I think about the unit circle, this angle right there is 2.118 because that's where the cosine is equal to negative 0.52. We know that cosine is negative over here in quadrant 2, right? Because the x's are negative. And that means there's another angle down here that has the exact same cosine being negative. So you see how up here I had the red lines, so those are the two places that the first side corresponds to this one. This other one corresponds to this other angle. So what are we going to do? I know that this is going to be, if I could find that reference angle, then I could find this reference angle, and I add that reference angle to pi. So let's see. So pi minus 2.118. Let's see. So second pi minus 2.118 is 1.024. So this angle here, let me go to a different ink. This angle here, that reference angle is 1.2, see, let me write it better, 1.024. And I know this angle down here is also 1.204 because it's going to be the same. So I'm going to take pi and add it to that. So second pi plus that number. So that's 4.165. And I know that both of these are equal to 5 pi, pi over 5 plus times t. So all we're going to do is take this number, multiply it by 5 over pi, and that'll be the first time. So, and then we're going to do the second number times 5 over pi also. So let's see, I've got both of these on my calculator. So I'm going to do times 5 over pi, 5 divided by pi. So that's, for that second point, it's 6.629. For that other one, let's see, I'm going to take the 2.11 times that by 5 divided by pi. That's giving me 3.37. So I just got to subtract those two times. And that tells me this Ferris wheel stays above 20 feet for 3.259 minutes. And I could be convinced, because I know that I can be convinced that's true, because we know this is 5 minutes halfway around, right? So, and that's going to be a little bit more, certainly more than 2.5, less than 5. So that's why I'm okay with that. So that's how I solve these kind of questions. You could do some other things with finding the angle between. Here, let me do a new picture. You could do you could do it this way. I've seen people do it this way, and it certainly works. You could say, okay, I know this angle. If I could find this time, I could just double it, because it'll be the same over here. So yeah, I mean, there's plenty of ways to do that. It would be this time minus 5, right? What was it? What was that? 2.11. That was the angle. It was 3.25. So you could say, so this time is 3.25. No, that was halfway, wasn't it? It was 3.77. This time was 3.77 when it was 20 meters high. And we could take that away from 5, because we know that's the peak, and then double that time. You could do it that way too, and that certainly works. Okay, so hope this helps you with both section 6.1 and then again 6.4.